This is Ravi S. Kulkarni, lecturer in chemistry. So today I am going to deal with a topic for PUC second year science chemistry, that is what amines. And also one more name for this amines is organic compounds containing nitrogen atoms, that is also called amines also. Both are same. So here let's see what are the amines. Amines are nothing but these are the derivatives of ammonia. You know the very well about the ammonia. Ammonia is NH3. So simply I am going to write as ammonia, where 1 or 2 or 3 hydrogen atoms are replaced by alkyl groups. Alkyl groups nothing but they are the aliphatic groups. Like example CH3 methyl group or ethyl group C2H5, or it may be aryl groups also may be attached here instead of hydrogen atoms. Aryls are nothing but example benzene, phenyl groups. Okay, so these are the derivatives of ammonia. So we when 1 or 2 or 3 hydrogen atoms are replaced by alkyl groups or aryl groups, and simply it's a functional group of amines is nothing but NH2. So NH2 is a functional group of amines, and due to the presence of this lone pair of electrons on nitrogen atoms, so these compounds act as a bases. So ammonia is a base compound, and similarly amines are also base compounds. So this is the introduction of amines. Before going to study of amines, first you should study the structure of ammonia. How it will be formed? Simply we tell that ammonia is a sp3 hybridization. So then we should come to know how it is formed the sp3 hybridization. Okay. First you know that first I take the ammonia. Okay. Ammonia, you know that here nitrogen is the central atom. So nitrogen atomic number will be 7. So now I am going to write the electrons in the respective orbitals. That is 1s2, 2s2, 2p3. See here 7 electrons. 2 plus 2, 4, 5, 6, 7. What happens? These are called as paired electrons, and these are called as unpaired electrons. Unpaired means only single electron in the orbital. So what happens now here? So these we should not consider here, because these are the completely filled orbitals. Okay, these are the completely filled shells. So simply we can count as it is a K shell. So only the matter of deal with only these orbitals. What happens here? So in order to make this a bond, I am going to take the 3 hydrogen. So what happens? 3 hydrogen atomic number, you know that 1s1. So simply I write 1s1 3 times, because 3 hydrogen. If you want to make a pair, so what happens? These electron in the 1s1 orbital of hydrogen, which is going to make pair up with this orbital. Similarly, this electron going to be pair up with this orbital, and this going to be pair up with this orbital. So after that, what happens? It forms as like this forms. So this is nothing but bonds. That is how it forms. This is the formation of the, here there will be unpaired electrons in the p orbitals. Here utilization of the 3 p orbitals of the nitrogen atom with 1s1, I mean 1 electron in the s orbital of hydrogen, which is going to form the hybridizer. Hybrid is nothing but mixing of the orbitals. So how it is mixed here? S orbital, which is going to mix with the 3 p orbitals of the nitrogen atoms, then that's why it is formed. So like this. So how I am going to write here? NS3. So NS3 I am going to write as like this. NS3. So because of mutual sharing of the pair of electrons. So here hydrogen is going to pair with this p orbitals of nitrogen. That's why here 3 bonds will come. Then whatever these electrons, these are nothing but non-bonded electrons, or simply we are going to call it as unshared pair of electrons. Unshared nothing but lone pair of electrons. So these are called as lone pair of electrons. So that's why it is due to the presence of this lone pair of electrons on nitrogen, it is going to act as a base. So its hybridization is sp3. Once again, S from the hydrogen orbitals and 3 p orbitals from the nitrogen atoms. So you know that sp3 hybridization always contains the bond angle as 109 degree, 0.0 0.08 minutes, like this will be there. But what happens here, due to the presence of lone pair of electrons, this sp3 hybridization of ammonia gets reduced to 107 degree because of the lone pair of electrons. So this is the structure of ammonia. So just now we have discussed about the structure of ammonia. So similarly, structure of amine is the same way, but only what is the difference here? So this is also same, sp3 hybridization. But what happens? 3 hybrid orbitals of the nitrogen is going to be make a bond with carbon atoms. Carbon atoms here, these are the alkyl groups. Just I have substituted this because I told that amines are the derivatives of ammonia. So here R group is nothing but alkyl groups. Alkyl groups is nothing but carbon atoms. That's why 3 p orbitals of the nitrogen which wants to make with the carbon atoms, that is alkyl groups. So remaining this is a lone pair of electrons. This is called as unshared pair of electrons. So this is the sp3 hybridization, and according to VSEPR theory, valence shell electron pair repulsion, what happens here? The lone pair and this bond pair. This is called bond pair and this is called lone pair. So according to this theory, lone pair and bond pair repulsion, the bond angle it goes to 108 degree. So in previous we have seen the ammonia what bond angle was 107 degree. Because we give the statement for this 107 degrees, due to the presence of the lone pair of electrons, it gets reduced to 107 degree from 109 degree. But here it is increased to 1 degree because of the parameter of the bulkier group. Steric repulsion. So due to this steric repulsion, bond angle goes to increases by 1 degree from the ammonia. Next, we see the classification of amines. Okay, as I told that amines are the derivatives of ammonia. Okay. Amines are the derivatives of ammonia. So what happens here? So based on the number of hydrogen atoms which are going to be replaced by alkyl groups or aryl groups. So based on, we are going to classify it as 3 types. So first one is called primary amines. Primary amines is nothing but, so here NS3 is there, ammonia is there. So I am going to replace this hydrogen with one alkyl group. So that is what replacement of one hydrogen atom from the ammonia molecule, that is called primary amines. So simply I am going to write it as NS2. So this is the functional group for the primary amines. What I have did here, only I removed one hydrogen, just I had one alkyl group, or it may be aryl group. So let's see the example for this primary amines. So I told that if alkyl group is replacement takes place, then we are going to give some examples. And if this hydrogen is going to replace with some aryl groups also. So example is, I am going to take now here CH3NH2. CH, this is alkyl group. So its name is methylamine. So this is called alkyl amines. So similarly, I am going to take one example for the aryl amines also. Aryl amines are, this is called aniline. What I did here, only that is replacement with one benzene ring. So that is called aniline. So these are the example for primary amines. So next, second one is called secondary amines. What do you mean by secondary amines? So here the replacement of 2 hydrogen atoms with alkyl groups or aryl groups, they are called as secondary amines. Here I am going to replace 2 hydrogen atoms. So that's why its functional group is, I am going to write as like this. So example for this is So this is called dimethylamine. So this is the example for aliphatic secondary amine. So similarly, I am going to write for the aryl. I am going to example as piperidine. This is the example for piperidine. So this is aryl secondary amine. Similarly, last one is tertiary. So last one is tertiary amines. So here replacement of all hydrogen atoms from the ammonia molecule. So I am going to give that it's a functional group. This is, I am going to write as, this is the functional group of tertiary amines. So example is trimethylamine. These are the alkyl tertiary amines. And one more example for aryl tertiary amine is this is pyridine. This is the example for tertiary amines. So that's why we are going to classify based on the number of replacement of hydrogen atoms with alkyl group or aryl groups. We are classified as primary, secondary, and as well as tertiary.